Alright class, so I'm going to help you out with problems 12 through 15 on homework set 6 and cement and ag. Okay, number 12. So I'm not going to solve them all, but I'm going to help you get them started. Okay, number 12, a 3 cubic foot container, so 3 cubic feet. So is that a total volume? Yes. So VT, write down what the problem is giving you. It was 3.000 cubic feet. Okay. Full of moist sand, has a wet density, so wet density of 126.8 pounds per cubic feet, and then the formula for wet density is total weight divided by total volume, and a moisture content of 10%. Water content equals 10.00%. And that formula is weight of water divided by weight of solids times 100. Okay? All right. Specific gravity, GS, 2.712. Okay? So we know that formula is unit weight of solids divided by the unit weight of water. We know this is 62.4, and we know this is weight of solids divided by volume of solids. So that's everything that's given to us. So it's asking us, okay, what is the solid volume of sand? So we're asking for volume of solids, the volume of water, and the volume of air in the container. So volume of water, volume of air. All right, so let's do our handy dandy phase diagram here. I guess it doesn't need to be that wide. So we have air, water, solids. We have total weight. This is weight of air. We know that equals 0. Weight of water. Weight of solids. And then we have our volumes on this side. Total volume. Volume of air. Volume of water. Volume of solids. And then we know this is volume of voids. Okay, so we know the volume, total volume is 3.00 cubic feet, right? So our volumes are cubic feet, our weights are in pounds. Okay, what else do we know? Water content, specific gravity. We have a wet density. Can we find our, okay? So we need to find air, volume, and solids. Okay? All right, so wet density. All right, so first thing what we need to find, for us to get the volume of solids, the key is to get in the weight of solids. We need to find the weight of solids. Okay, so here's my, so first thing I'm going to do is I'm going to take gamma wet equals total weight divided by total volume. Okay, so if I can take the unit weight, the wet unit weight times the total volume, that'll give me my weight total, right? Okay, so now I can take weight of solids equals weight total divided by 1 plus water content divided by 100. That'll give me my right? So this weighted total goes to this weighted total, and that'll equal weight of solids. Okay? All right? So once we find that, that's a start. Okay? So we want to find weight of solids with weight total. All right. So we have weight of solids. All right. So now, once we know total weight and we know weight of solids, we can find weight of water. Weight of water equals total weight minus weight of solids, and that equals weight of water. All right, so now we have weight of water. Okay, so now we can go 3. We know the unit weight of water equals weight of water divided by volume of water. So if we know this is, remember this is a constant, 62.4 pounds per cubic foot. Can I rearrange this to find my volume of water? Absolutely. So we go, so when I rearrange this equation, that is weight of water divided by the unit weight of water, because I found it from step 2, equals volume of water. Okay? So now we can find volume of solids by using GS equals unit weight of solids divided by unit weight of water. Okay? Specific gravity of solids. So if I take my specific gravity times my 62.4 pounds per cubic foot, I will get my unit weight of solids. Right? Now I know unit weight of solids equals weight of solids divided by volume of solids. We know weight of solids all the way up from here. Sorry, you probably can't see that. Alright, so let me, oops. I have no idea what just happened there. Let me pause this for a second so we can, sorry about that. Alright, so we find unit weight of solids. Okay, we know the weight of solids from up here, so now we can take weight of solids divided by the unit weight of solids will equal my volume of solids. Alright, so now we'll have our volume of solids and volume of water. So now we can figure out our volume of air equals total volume minus volume of water minus volume of solids equals volume of air. So, boom, boom, boom. We just solved that problem. Okay, so that's number 12. Again, this is number 12. All right. Let's do number 13. Okay. 13. A cubic foot container is filled with 345 pounds of dry sand. Okay. Total volume equals 3.000 cubic feet. Okay. It's filled with 345 pounds of dry sand. So weight of solids equals 345 pounds. All right. Water is then added to the container such that all air is removed, saturated. So that means volume of air equals volume of water. So that means basically volume of air equals 0 in the phase diagram, right? Okay. The specific gravity of sand is 2.70. GS equals 2.750, which equals unit weight of solids divided by unit weight of water. What is the weight of the water added to the container? So we're looking for weight of water. All right. Oh boy. So in our phase diagram, okay, so we have total weight, we have air, water, solids. Okay, 3 cubic foot. So we have a total volume. So we know our weight of solids. This is weight of air, weight of water, weight of solids. We're looking for weight of water. So we know this equals 345 pounds. Okay? All right? Okay. Knowing that that's 345 pounds, okay, and we have a total volume, we can calculate a dry density, but that dry density is based on a total volume. So we need weight of water. All right, so I'm thinking I don't have any other information. So unit weight of solids, unit weight of water, so I can find my unit weight of solids. Okay, so how am I going to find that? So step one in the solution, because I'm looking for this term. We know this equals 0, but I don't have a total weight yet, do I? And I don't give you a water content. So the only thing I can work with is the specific gravity. So GS times the unit weight of water equals the unit weight of solids. So 2.750 times 62.4 pounds per cubic foot will equal my weight of solids. Okay? So now I know weight of solids equals, or my unit weight of solids equals weight of solids divided by volume of solids. All right? Okay. So my volume, so can I find, so I have weight of solids, I can find my volume of solids. Okay? So let's take, we know weight of solids, and divided by my unit weight of solids, now give me my volume of solids. Okay? So this to this to this. Now knowing my volume of solids, I know my volume of water, which equals volume of voids, right? Because volume of air plus volume of water equals volume of voids. Okay? Let's go to the phase diagram. Volume of air, volume of water, volume of voids, total volume, okay? Volume of solids, right? So we know volume of voids, so volume of air equals 0, okay? Right? So that means our volume of voids equals our volume of water because the voids are filled with water. All right, so knowing that, okay, let's find what can we determine from that. So we know density of water equals weight of water divided by weight of solids. Would you agree? We know this, so I may not even need this. This equals 62.4 pounds per cubic foot. Do we know my weight of solids? Yes, because I gave it to you right here. So unit weight of water times weight of solids will equal my weight. Oh, I'm sorry. Back up. That's moisture content. I do need that. Apologize. Oh, okay. Unit weight of water times the volume of solids will equal times the volume, volume of water. This is unit weight of water equals weight of water divided by volume of water, right? Density. Unit weight of water times the volume of water will equal the weight of water. Okay? All right. So now knowing volume of solids up right here, okay, because I have my specific gravity, I find my volume of solids, I know volume of water equals total volume minus volume of solids. And that'll equal volume of voids, which equals volume of water because the voids are filled with air or with water. So this will go right there. You know this number. Then you can get your weight of water. So the trick to this problem is understanding that the volume of air, it's saturated, so the volume of air comes to 0. So the volume of water equals the volume of voids, and then we back calculate. So hopefully that explains it in a nutshell. All right. Okay. Sorry. All right. Number 14. 5-gallon pail. All right. So 5-gallon pail. So total volume equals 5 gallons times 7.481 cubic feet per gallon, right? The gallons cancel out when I'm doing process of or dimensional analysis to convert units. My gallons is, so this is, you can pretend this is over 1, right? So if you pretend it's fractions, that's how I know where do I put the cubic feet, on top or the bottom. If it's in the top before, it has to be on the bottom in the next term, and they cancel out. So 5 times 7.481 equals, so 37.41 cubic feet, which equals our total volume. Okay? 5-gallon bucket, completely filled with dry sand. So there's air in there. Okay? So that's our total volume. That includes the air, but no water. Okay? We determined that the sand has a specific gravity. Okay? GS equals 2.750, which equals unit weight of solids divided by the unit weight of water. Okay? We are able to pour 2 gallons of water such that all of the air is removed. So volume of water equals 2 gallons times 7.481 cubic feet per gallon. All right. Okay. 2 times 7.481. That equals 14.96 gallons, which equals volume of water. So that means it says that all the air is removed. So volume of air equals 0. That means volume of water equals volume of voids. Okay? So what is the weight of the dry sand in the pail and the moisture? Okay, so we need weight of solids and weight of water. Let's do our phase diagram. Okay, I'm not doing this in order, but I'm just talking you through this so you can start. This will help you. All right. Air, water, solids. Total volume equals 37.41 cubic feet volume of air, that equals 0, right? Because the water filled in the voids, the air voids. Volume of water, we put 2 gallons of water in there, then that equals, this isn't 14.96 gallons, this is 14.96 cubic feet, because the gallons cancel out. So this is 14.96 cubic feet. Okay. So, can I calculate volume of solids? Yes. This equals 37.41 minus 14.96, because this is in cubic feet. Okay? All right. So let's go to our weight side here. Do we have a total weight? No. Okay? This is weight of air. We know that equals 0. Weight of water, that equals something. That's what we're looking for, right? And we have weight of solids, which we're looking for. All right, so knowing GS equals the unit weight of solids divided by the unit weight of water. Okay, we know unit weight of solids equals the weight of solids divided by the volume of solids. Okay, look at this. So I know volume of solids. I can calculate this, can't I? So I'm going to take GS, my specific gravity of solids, times the unit weight of water, which is 62.4, and that equals my unit weight of solids. Once I know my unit weight of solids, okay, I plug it into this equation. Now I can take unit weight of solids times the volume of solids, because I already calculated it right here, okay, because I know my volume of water and volume of solids equals my weight of solids. Okay, so now I found my weight of solids. So now I have this, but now we need this, right? Do we have a total weight yet? Okay, so I found this. Here's my weight of solids. Now I need to find the weight of water. Density of water equals weight of water divided by volume of water. Do we know the volume of water? Yes. Do we know the unit weight of water? Yes. Can I, because I know my volume of water, can I rearrange this? So unit weight of water, that's 62.4 pounds per cubic foot times the volume of water will equal my weight of water. There we go. I just found my weight of solids and my weight of water. All right. All right. Last one, 15. A 1.5 wide by 1.5 long container. All right. 1.5 feet by, obviously this is a square, right? Contains 330 pounds. 1.5 by 1.5 long. Container contains 330 pounds of dry sand. So weight of solids equals 330 pounds. Okay? With a dry density of unit weight dry, 100 pounds per cubic foot. 100 pounds per cubic foot. We know that is what? Weight of solids divided by total volume. That's the formula for dry unit weight. How high does the container need to be to hold the sand? Oh, I like this one. All right, so we need 3 dimensions here, right? So if I right? So we have 1.5, 1.5, and then that's a horrible 3D. And then let's see, there we go. So this is my width, this is my length, right? So how high, this is my height, okay? So we know volume equals area times height, right? So we know our area is 1.5 times 1.5, and that equals, oops, I better hit the continue button, sorry. So we know volume equals area times height. So I have, this is my width, my length, and my width. I'm looking for my height to fit that sand in there. So 1.5 times 1.5 equals 2.25. So 2.25 square feet times H will equal my total volume. Okay? So we know dry unit weight equals weight of solids divided by total volume. So I know my dry unit weight equals 100 pounds per cubic foot. My weight of solids equals 330 pounds, right? And then my total volume equals 2.25 H. So I have a variable in here. So the H is in this here in the VT. So now I gotta solve for that. So weight of solids divided by the dry unit weight equals the total volume. Okay. Just ordering my steps here. All right. Now let's solve that. So weight of solids is 330 pounds divided by 100. 330 divided by 100 is 3.30 cubic feet. So I know total volume equals 2.25 H. So plug and chug, 3.30 cubic feet, which equals 2.25 H. Divide both sides by 2.25. 5 H equals divided by 2.25, 1.47 feet. Bada boom, bada bing. There we go. That's how high that box needs to be. All right, so with that, I just went through 12 through 15 in a really quick nutshell. So hopefully this helped you, and have a wonderful day.